In this video, we are going to show a workflow built with the KNIME Big Data extension and running on an Hadoop cluster first and then on a Spark cluster. The workflow was designed to include some classical preprocessing and machine learning steps. If you watch closer, this workflow actually presents the same functionalities as showed in the video KNIME Analytics, a review. However, this particular workflow has been designed to run on an Hadoop cluster and on a Spark cluster. The problem at hand is the prediction of departure delays on the airline dataset. In the first meta node, we let the user select the big data platform, the data subset to use for training and testing, and the external data sources datasets to blend with the airline dataset. The full dataset has been preloaded on 3 different data platforms: Athena, Redshift, and Hive, all on an Amazon cloud server. For this video, we decide to access the data on Hive. This selection enables the branch in the switch block with the connection to the Hadoop Hive platform. Once the connection has been established, we proceed with a number of nodes for in-database processing on the Hive platform: database row filter, database numeric binner, database switch, database joiner, and many more similar nodes generate SQL commands through a GUI, exactly the same GUI available in the corresponding nodes operating on traditional data in the KNIME Analytics platform. This makes the transition from KNIME GUI on traditional data to KNIME GUI on Hadoop and later Spark very easy for data scientists. Together with these in-database processing nodes, we also find a SQL query node to generate free SQL code. In these 3 meta nodes, we build a relatively complex SQL query to define all required constraint and blending operation on the original data. It all runs on Hadoop Hive till this toSpark node. As you probably already understood, in the toSpark node we pass the data from Hive to Spark and we continue with our processing and analytics completely on a Spark platform. The key node here is the Hive to Spark node that converts the Hive query into Spark RDD. There are many more similar nodes: Hive to Spark, Spark to Hive, database to Spark and back, CSV to Spark, JSON to Spark, and so on. Those are all nodes that upload and download data respectively to and from a Spark platform. As of KNIME Analytics Platform 3.4, Spark nodes all support Spark 2.0. All these nodes implement Spark commands through a GUI, similarly to the GUI used in Hive and classical KNIME nodes. The Spark Java snippet nodes allow expert users to write free Spark code and start their own Spark jobs through the new Spark Data Frame API. These 3 nodes implement the preprocessing phase this time to be executed on a Spark cluster, handling missing values, converting category values into numbers, dimensionality reduction based on a low variance, and a high percentage of missing values in a column, and a high correlation between 2 columns. Binning on the flight distances, partitioning, and finally normalization. In the bag of models metanode, a further dimensionality reduction is performed using k-means clustering. On the reduced dataset, we train different models via the Spark machine learning library: gradient boosted trees, random forest, decision tree, and logistic regression. Other machine learning models are available for training via the integration of KNIME with the Spark machine learning library, like support vector machine, naive bayes, etc. Since bit performances on Spark can be noticeably faster, we actually applied a cross-validation loop to each one of these nodes to calculate the average prediction error. All model performances are compared to the performances of a pre-existing model for A/B testing. On top of it all, we actually applied an optimization loop to optimize the number of clusters K in the K-means node. Notice that we are implementing here a mix and match approach. Most of the training and other calculations is run on Spark, but loops and performance comparison is run in KNIME Analytics platform. This allows to take advantage of the flexibility and coverage of KNIME platform and of the speed of the Spark platform. Results obtained with this workflow in Spark are comparable to the results obtained with a similar workflow running on KNIME Analytics platform, but with the advantage of a very high speed of execution.